Oh, I do love that song so much. Metal Christmas, man. I love the Metal Christmas. Oh, well, everybody, thank you very much. Welcome to Tuesday night. Dave Kircher says Tuesday. Thank you. I'm so excited. This was going to be Mallory and Bryant Myers. Mallory got sick. She did not get permission to get sick. I don't know why she did that without permission. We're going to try to do it in January, the first week in January. We're going to see. But Mallory, she's anyway. So I am talking tonight about a common misconception among both flat earthers and globe earthers. Almost every flat earther gets it wrong. And a large number of globe earthers get it wrong. So that is what we're going to be covering. But most importantly, let's just get this straight right at the beginning. Flat earthers do not want to actually test their claims. Cult leaders and cult members never like having their their claims tested, right? So there is bottom-up obstruction when things get farther away. No doubt about it. You cannot deny it. But what causes it? That's the question. Is it the curving surface of the earth, or is it some other thing that flat earthers have proposed? Typically, they just propose something that's a vague collection of words. They'll say things like refraction, diffraction, angle of attack. Give me in the chat here. You can participate with the ones you've heard. Perspective. I've actually heard a flat earther claim that perspective causes light to bend. Flurfspective is what we sometimes call it then. They say it's occlusion by moisture in the air. Sometimes they say vapor. Sometimes they actually say droplets. Sometimes they say it's just too far to see. Sometimes they say the light got tired, right? Inverse square law, the light got tired for some reason. None of it makes sense. None of any of those things actually make sense because, and this is super important for you flat earthers, this doesn't make sense because if any of those reasons were why you didn't see the distant objects bottom up, you would still see the gap between the surface of the water, because these are usually over water, the surface of the water and the part of the object that you can see. There'd be a gap there. It just be blurry in most of the proposed explanations. You just have a blurry part, right? They're like, well, the angle is too tight. Well, hold on a second. It's almost perpendicular, right? And down here, it's almost perpendicular, but just a tiny bit less perpendicular. This is the object that's being obstructed, right? And up here, it's also just a little bit less perpendicular, but for some reason, the part up here isn't obstructed, just the part down there. None of these things work, flat earthers. None of your proposals work. So here's what I want flat earthers to provide. You won't. No flat earther will do this. Guaranteed. In science, you make a hypothesis, and then you compute the consequences of that hypothesis. Your hypothesis is refraction, diffraction, angle of attack, perspective, curvilinear perspective, foreshortening, limited field of view, all sorts of things that you say that it is. Whatever that is. How do we compute the consequences of that claim? How? How is that done? You want to do science, you have a hypothesis. So far, it's one of the worst hypotheses ever. It's just this vague collection of words with no plausible mechanism for what causes it. Nothing. It's a failure out of the gates. You need to go to the next step. You need to compute the consequences of your claim. So you need to provide the formula for flat Earth that predicts the bottom-up obstruction. Whatever are the particular things that you say causes it. Is it the weather? Is it water droplets in the air? Is it diffraction, refractioning? Whatever copy-paste nonsense Gary Wybenga is going to be in here with in a few minutes. How do we compute the consequences of it so that we can test your claim? See, cult members and cult leaders never want their claims tested. They will not give the mechanism for us to test their hypothesis because they know as soon as we test their hypothesis, it will be falsified. I'm happy to have the globe hypothesis tested. I'm going to show how to do that. So how is that done? Well, the first thing, and the title of this, the thumbnail for this is 8 inches per mile squared is almost never what flat earthers want. And then the text of it calls out Professor Dave. Professor Dave is not the only one. In fact, I saw it today on Facebook. I saw it a few minutes ago in a debate I had on somebody else's channel. Globe Earthers saying 8 inches per mile squared is wrong. And the reason why is they say it's because it's a parabola. And that's not the reason why. 8 inches per mile squared is the wrong formula for bottom-up obstruction. It's the right formula for drop from a horizontal tangent at a point. So what does that mean? I could draw a picture, but I'm not going to do it right now. Because that would be, it'd be some dead air. So you go to the surface of the Earth. It's a curve. And at that point that you're at, straight up is called zenith. And orthogonal to that is a horizontal plane. And so if you take an autolevel or a theodolite and you take the theodolite and you turn it to 90 degrees so that it's orthogonal to zenith, or an auto level, which does that automatically, or a transit level, there's a few other things. And then you look at some distant object. If you know the elevation that you are above sea level, above a lake, say, that distant object will drop if it's at the same elevation above it. So if you're at 5 feet above the lake and that distant object is 5 feet above the lake, it will drop approximately 8 inches per mile squared. That's the correct usage for the formula. It's an approximation, but it's close enough for any observation that we're basically ever going to see on the globe. It does not account for refraction. So if the refractive conditions are strong, then you're going to need to use something else to account for that. You could adjust the 8. That would be one way, or you could come back later and apply some adjustment for refraction. I don't know. I've not looked into the way to do it. I do know how, I should say. 8 inches per mile squared. The 8 came from somewhere. If you look at the derivation of 8, it comes from the radius of the Earth. The radius of the Earth is in there. One way to approximate the effects of refraction is, instead of using the measured radius of the Earth, you adjust it. You multiply it by a modification factor. And so you'll get a different number than 8 inches per mile squared. You'll get probably I think you'll get a lower number. Yeah, you'll get a lower number if you increase refraction. So you might get 7, you might get 6, depending on the quantity of the refraction. So if you don't know the amount of refraction, it's going to be really difficult, right? So that's the right formula for drop. It's the wrong formula for bottom-up obstruction. You can use it for bottom-up obstruction, but it's a 2-step process. step one, you need to get your distance to the horizon, accounting for refraction. Step two, then you can apply 8 inches per mile squared, because that's the point that's going to be tangent on your line of sight between the object and you. So you need to know your distance to the horizon. Without refraction, there's a formula for it. But since there's over water, there's always refraction. And it's typically rather high over water. So, all right. Let's see. So drop alone doesn't give you very much. Yeah, real sickness. So I will show you how to apply drop. How to apply drop. Now, flat earthers that are watching along, I am challenging you. I want you to get your see too far observation. I already have one that was sent to me on Discord, and I'll pull that up. So I want your see too far, and I'm going to put on the screen here the how it's done. So all right, all right, I'm going to put on screen what you need. There it is. Okay, I lost track. Right up there. This is what, if flat earthers, if you think we see too far and you have an observation, here's your list. This is what you need. You need the location of the observer. You need the elevation of the observer. You need the location of the object, the elevation of the object, and the measured vertical temperature gradient. Now, rarely is that done. I have seen a few times where it's been done. If you don't have that, that's fine. We have to get an estimation. So then we want the local weather conditions, the time of day, whether or not it's overcast or sunny during the day. So, Timbo Turtle. So, all right, we got Y Kikamuka says, did Mallory eat too many burger sandwiches? Oh no, I don't know if that'd make her sick. I think she had, that's been going around. I think that's what it was. It took her down for quite a while. Timbo Turtle says, 0.2032 meters per 12874.8 meters squared. Non-freedom units. Okay. I think he just converted it. So Matt Patak says, zoom back in, eye level, and Bev doesn't shut up. Nope, he doesn't. All right, now Eddie Reese. Eddie Reese just posted the wrong formula. Eddie Reese gave H equals R minus R cosine of S over 2R. That's the non-approximation formula for drop. It's also the wrong formula. Now, I've had a conversation with FTFE on this. He has said parabola in the past. It was wrong. He has said that he has given that formula, Eddie Reese, in the past. It's wrong because flat earthers aren't interested in drop. Usually. Force the line. I didn't look enough into it, but somebody said that force the line. They did look into it. But here I'm going to show you. Jesse Kozlowski has his lake, his perfectly level lake observation. I'm going to jump right on down here to the results. If you've been around a bit, you've seen me use this before. Jump all the way down to the results. And you can find it by just typing Jesse Kozlowski level lake. And Google will probably give you a suggestion on it if you just start typing Jesse Kozlowski. All right, this is his bigger one. He's very much detail on this one. Come on, we're almost there. Remember from last week, this is the one that Ryan did not like. Okay. So right here, we have the tabulated results. And if you look at that, 1.38 miles. And the drop, 1.28. Now that is a measure of feet. That is a measure of feet. So decimal feet. It's weird. American surveying is still in decimal feet. Facty. I used the pirate formula. R over water. Oh my gosh. So there. You go. Go ahead. Do it yourself right now, people. Take 1.38 and apply it to 8 inches per mile square. And then you got to convert to feet. And you will find, you will get, and you know what? I have not personally tested this particular one. I've tested the other one. But I will state very confidently that if you use 8 inches per mile squared on this particular thing here, you will get 1.28 feet. Here's the other one, the one that I have personally tested. I'd scroll fast, smarter this time. So here it is. Same thing, the tabulation, 0.48 miles. You see that? And the drop from horizontal plane, 0.15 feet. So that's less than 8 inches because it's less than a half a mile. There you go. American units are weird. You're right. They're definitely weird. All right. So Timbo Turtle, what do you got there? So there's like in all math. Where is it? There it is. Nope, not yet. It's on my website. If you go to my website, you search for curve. You will find I actually have right there the formula. So there's the actual formula. Right, so Timbo Turtle put in a formula that might be the other one. Now I give you a link here to Walter Bislin's page, which includes the actual derivation of it. So good on him for the derivation, and the screenshot that I put in there is actually his. This is just you see this right here, Formula 6. Right, that's just a screenshot of his. So Walter Bislin, thank you very much. It's your screenshot. Here's the other one. Does this match? No, it doesn't quite match either. That Timbo Turtle put up. So I don't know what you have there, Timbo Turtle, but I don't know what D is. I don't know what, anyway. So there's two formulas. One is for straight distance through the air, and the other is for the distance across the surface of the Earth. So when you use Google Maps, you're going to get the distance across the surface of the Earth. So you want to use the second formula there. You can see H0 SH, distance to the right. Oh, no, wait, I'm sorry. Hold on a second. This is the wrong formula. There is the right formula. There it is. Okay, Timbo Turtle. Hold on, let me fix that. Timbo Turtle, yours looks pretty similar to this. It's not quite the same formation, but in math you can arrange things differently, as is your preference, but it looks pretty close to that. That might be the one. So Formula 3, I think, is what Timbo Turtle has. Formula 4 is the one that I have on my web page there. And the reason why I use Formula 4 is because it uses this lowercase s, distance between the observer and target along the surface of the globe. And you've got then Formula 3 there uses this lowercase d, which is the line of sight distance between observer and target tangential to the surface of the globe, which we don't get when we use Google Maps. So it's not typically the formula you'd want to use. It's this other one here. But it doesn't matter, because you don't need to apply it yourself, because Walter Bislin put it into this web page. It's nice and easy to do. Right. So what are we going to do? We're going to do, Flat Earthers, contact me if you think you have the one photo that is too far, but I'm going to go to the one that they use the most often. And what is the one that they use the most often? It is Chicago skyline. And I have the Chicago skyline. I went to just Joshua Nowicki's Facebook page, went all the way back to May of 2015 to get the highest quality picture of it that I could find. And this is it right here. This has not been cropped. You can see it's got his whole name on it. This is the one that he published, and this is Chicago skyline. Now, Flat Earthers always, every time I've ever seen a Flat Earther talk about this, I can't think of one exception. Maybe I'm wrong, but every time flat earthers talk about this, number one, they use 8 inches per mile squared. Wrong formula. Number two, they almost always, when you ask them what was the height of the observer, they say, what do they say? They say 5 feet above the water. That is an outright lie. They did not do their own research. No surprise that a flat earther didn't do their own research. So you can see, let's zoom in here a little bit. Let's just to be clear, flat earthers, this doesn't actually help you. Because you know what they say? They say, when this picture isn't visible, they say all of the skyline is visible. They do say that. But if anybody's ever been to Chicago, you know there's a road that goes right along there. Lakeshore Drive. It's over on the right side. It'd be on the north end here. You can't see Lakeshore Drive. You would see it. This is nighttime. You'd see all the lights from the cars. You can't even see street lights here. Nothing. There's no street lights here. Flat earthers, where are they? Why is everything missing? Right? This tall one over the right, that's John Hancock. The far one on the left, no. I think John Hancock's in the center there. Yep. And on the left is Willis Tower. Used to be called Sears Tower. Yeah, Lakeshore Drive, Matt Patak, thank you for that. I've driven Lakeshore Drive. That would be underwater according to this. So with flat earthers, it is incumbent on you to provide the plausible mechanism and the testable hypothesis with the computation of the consequences for what's causing this bottom-up obstruction. Just saying a whole bunch of words is not a testable hypothesis. Okay. So let me get to this. Flat earthers never did this. They never did this. They never checked to see the elevation. So when you actually pay attention and you go read when he was interviewed by the news station, he says he was up on the bluff there, right? We don't know the exact position, but there were some other photographs and videos from that exact same spot. And you can actually see some of these little trees here. If you go on closer, you look in here, you can see some of the trees. Doesn't matter a ton because the elevation isn't super accurate even on Google Earth. This is from Google Earth. And so you can see here 723 feet, I think is the elevation of the surface of the water. And then at the top there, 766, I think. Is that right? 4,000 feet. I don't know. Anyway. Oh, no, the eye height is that's the eye height. All right. Well, I have all the details that I have put in. So, all right. So the next is what's the actual distance? They say 59 miles. It's actually 53.3 miles. And then we go over to Bislin's advanced curve calculator and we put in the observer height. It's 180 feet above the surface of the lake. That's important. They never include this. Never include this. Because when you use 8 inches per mile squared, where do you put in 180 feet? It's nowhere. They're like, oh, I'll just subtract it later. That doesn't actually do it. That's still wrong. Flat earthers, do you want to be liars? You must use the actual globe if you want to test the globe. No, the target distance, 53.3 miles. Target size, 1,450 feet. That's the height of Willis Tower. And refraction, 0.5. That is the minimum refraction when you're looking over water. I would never consider using anything less than 0.5 unless the conditions were very, very obvious that it wasn't that high. And so let me explain. Standard refraction is not a great thing, but standard refraction is what some surveyors use when they're viewing things at height over land and the observation is not going near the surface of something. Then maybe you can use, in standard refraction is 0.13 in this. The U.S. Meteorological Society uses 0.33. Right? But that's, again, not over water at low elevation. So you need to use either a measured vertical temperature gradient, which there's only two I've ever seen. One is the FE core at Lake Balaton, which totally completely destroys them. It shows that the vertical temperature gradient is massively too high for here's how bad it is. A vertical temperature gradient of 1 degree Celsius per 10 meters will cause the light to bend in an arc of about 4,000 miles. Yes, I know I mixed units there. 6,371 kilometers, which is the radius of the Earth, the measured radius of the Earth that people have measured for centuries. It will cause light to bend at that particular 1 degree Celsius per 10 meters vertical. The Lake Balaton one had a more than 1 degree change in temperature over 2 meters. Significantly higher, significantly more than would cause the light to bend at the radius of the Earth. There's no way that you could then say that refraction did not happen. It's drastically strong refraction. And that's what happens at nighttime, or especially over frozen water or nearly frozen water. That's what was happening there. They're hoping it was going to be frozen. You have it maximized because the water is pretty cold compared to the air, especially if it's frozen. If it's frozen water, it's drawing moisture, or not moisture, heat from the air. So at real close to the surface, it's very cold. If you've ever been on a lake, a frozen lake in the winter, with good boots even, you'll know your feet get cold, even though the rest of your body might not be, because it's significantly colder down close. But on days that it was sunny and it's after sunset, you get drastic changes there too. So Lake Balaton, exactly what is predicted for the globe, or for temperatures in general, is that you'd have this high temperature gradient. The other one was Dr. John D., who's definitely not a doctor. He did one at Brighton, I think Brighton Beach, and they also measured the vertical temperature gradient in 2 spots. And it was also about, I think it was 1.5 degrees over 1 meter. Super high. All you need is 1 degree per 10 meters. It was doing it in 1 meter. So flat earthers, don't lie. Don't straw man to do your tests, right? If your position requires you to lie, it's pretty weak position. So, all right. There it is. Refraction 0.5. And we see hidden 300 feet hidden of 1,400. We can go back and look at the picture and see, well, does that match? So over on the left is the Willis Tower. Is 300 feet. Well, I don't know how much of it was hidden of 1,400 because we don't see the base. And it's a little bit of a blurry picture. It's a little bit difficult to actually get really solid things, but you could look at the other buildings and people could do an analysis of it. But the point is, you don't need to even do that. The point is, you should see the top part of it on the globe. No question about it. When you actually test the globe, you should see most of Willis Tower. Now, flat earthers, they don't get that. They'll say it should be hidden behind a mountain of water a certain height based on the wrong formula. Flat earthers, stop lying. And globe earthers, let me say this. I cannot stress this enough. Globe earthers, the problem with 8 inches per mile squared is not that it's a parabola. It's that it's a measurement of drop from horizontal. It does not do what they want it to do. It's not bottom-up obstruction. My website, just go to curvature calculator. Gives you the correct formula. Go to Walter Bisland's. It applies it correctly. Now, sad news. I'm gonna play this, and I emailed him. Professor Dave got it wrong. I'll do it right here. Professor Dave, in your 10 things that all flat earthers say video, point number 3, I believe, you said that they all say 8 inches per mile squared, and you're correct on that. And then you said it's wrong because it's a parabola, and you're wrong on that, Professor Dave. The reason why it's the wrong formula is because it's for drop, not because it's a parabola. When you use it for drop, it's fine. You are going to get, for as many digits of precision that you need for your observation, you're going to get enough digits of precision using that approximation. Because when you're looking at something over 60 miles or 100 miles, you're not getting 6 digits of precision. You'd be lucky to get 2 or 3 digits of precision. So Dave, I appreciate that video. It's a great video. And we're going to show it here in a second, but that particular part of it, you got wrong. So I got to put them at your buds. Springer News 1 says, no, the problem is that it's a straw man. Well, is it a straw man? I mean, yes, it's a straw man. And a lot of the time they don't mind doing a straw man. And they should have a problem with that. An honest person. And flat earthers claim to be about truth. How many of them have truth in the name of their channels? Way too many. So, all right. Here is, I'm going to jump back here. Oh, it's number 2, not number 1. All right. And look at that. It's this one. This one's a popular one. That's, is that in Canada there? All right, let's go.
I shouldn't see this thing, but I do, so the Earth is flat. Then, to justify this claim, you all say the same thing, typically with no context whatsoever. 8 inches per mile squared. None of you have any idea what this means. You can't derive it. You can't calculate anything with it. You can't make a prediction with it. You can't tell me anything about this value at all. When I point this out to you, you get very angry, and instead of answering simple questions, you just link me to a bunch of videos made by con men. Well, I'm sorry, friends. Those people are doing incorrect math, or lying, or both, and they are counting on the fact that you won't do any math at all to check up on them. 8 inches
All right, so far, Dave, spot on. Perfect. Absolutely got it.
per mile squared is not a valid way to measure Earth's curvature. If you understood math, you would immediately see that this squared on miles is totally out of place. That's because this is a parabolic approximation. This is for doing calculations with a parabola. It's possible that you remember this shape from middle school algebra, but I wouldn't be surprised if you don't. As you can see, the Earth is not shaped like this. So where does it come from, and why do people use it? It comes from the Flat Earth Bible, Zetetic astronomy, and Flat Earth priests use it because they know it's not accurate. It gives them incorrect values that they can use to claim that they shouldn't be able to see something when in fact they totally should. There are dozens of videos on YouTube demonstrating this, several of which reference the actual formula.
Okay, Dave, that's not the actual formula. That's the actual formula, Dave. So I sent Dave an email. I told him I was going to be doing this. I said I would invite him on. I will be in a little bit inviting I Can Science That to join me. So, because he did a great video on this as well, and I want to support what he was doing. And Raichi, we'll talk about Raichi when he comes on. So anyway, so that's the correct formula. Let's listen to the rest of Dave here.
That actually describes Earth's curvature, which as you can see requires trigonometry. Stop blindly repeating what you hear on Flat Earth videos and learn some basic math so that you can do these calculations for yourself. Number 3.
Okay. So there it is. And Matt Patak says not just Dave, but Simon Dan shows this parabola. And I had heard that. I did not verify it myself. But Dan, if you're doing it, shame on you. I'll message Dan later. It's again, use the right formula, use the right response. I saw it today. In fact, it was Zoomy, you naughty, very naughty Zoomy. Said it in the previous video I did, but we have a guest. Hold on a second. a second. We have, look at that. What do you think? This is Penguin. Hello, Penguin. Can we get Penguin there? Oh, right at the camera. Penguin looks like a teddy bear, doesn't she? She's so cute. Yeah, Mute Donkey's got the spelling right with the silent T at the beginning. She's constantly, she's either playing or sleeping. That's her two modes right now. So there it is. Look at these paws. They're big, you can tell. I love the paws of puppy paws. So she is cute. So there it is. All right, thank you very much. All right. Bob the science guy says, I use 8 inches per mile square and it works just fine over reasonable distances. I've measured myself over the lake, half mile, 2-inch drop. Drop. Yes, it's the right formula for drop. It's the wrong formula for bottom-up obstruction, right, Bob? And that's what I'm talking about, because when are flat earthers ever looking at drop? Bob, can anybody other than the one I already mentioned, when has a flat earther said, let's go and examine drop? They never do. So that dog is, it's not a terrier. It's a half schnauzer, half poodle. They call it a schnoodle. All right. So, all right, I'm going to fire up Zoom here, and we're going to send a message to both Dave and I Can Science that, so we can get them in. So, Coffee Breath has a schnoodle named Lego. That's a great name. That's a great name for a dog. All right. All right. So I'm going to send it to I Can Science that and to Dave. So I told Dave in the email, that I don't know if you'll be able to make it, but I will. I'll send you the link anyway. And Dave's invited. I said, yeah, you're short notice. I don't expect you to be there, but it'd be nice if you pop by. So would I get Neuralink? Very much probably not. So, all right. Okay, there's that sent to I Can Science that, and then I'm going to send it to, all right. I'm just talking so that it's not just completely dead air while I do this. All right, go to sent messages. Frank Burns, no, you goofball. There it is. And there it is, Professor Dave. All right. I Can Science that says, all right, 30 minutes. All right, I'll probably be here still in 30 minutes. I Can Science that. Okay, so flat earthers, again, flat earthers, get your stuff ready. I have one so far in Discord. And like flat earthers typically do, it's a crap observation. They don't like testing their they don't like testing their claims, right? Cult members and cult leaders hate having their claims tested. That's why they don't want to do it. That's why they don't want to do a good observation with quality control for confounding variables and things like that. All right. So I was sent this. This is from Ion, who's got this. This is a parabola versus a globe. So, and it's zoomable. So that's good. So we go all the way here. We'll zoom way in. And it looks like the scale, let's see, at this point we have 20 miles per thick box there. See that? So if we go 1, 2, you don't see my cursor, 3, 4, 5 to the right, that is 5 times 20, 100 miles. And you can see right there, right in this spot, you do see that dot there, right? That's 100 miles, I think. Right, here's, we got there. So, all right. So that's about 100 miles. You can't see the difference between the parabola and the surface of the Earth. And let's zoom in even more. and see how close we have to zoom. If you see that, you still know. Look at that. Just to see the little bit of difference. I think one's the geoid, actually. Right there. Anyway, look how close they are. It's very, very close. It's just fine. Just fine. So zooming back out. Yeah, thank you for that, Ion. And you can see it's a parabola. We'll zoom out. That's a parabola. It's fine. Nothing wrong with using that parabola for drop, but they're not looking at drop. So it's not the right formula. All right, let's get this one from Flat Earth Dweller Man sent me this one. And of course, if anybody's watched a little bit, this is starring Mikey Smith. Poor Mikey, he's been sick lately. So Mikey was the star of this one here, and let me read to you from Flat Earth Dweller Man. It says, irrefutable flat Earth evidence, missing curve over land. Now, you can see right above me, location of observer, elevation of observer, location of object, elevation of object, measured vertical temperature gradient. Lacking that, what's the conditions? They don't have any of that. They may have distance. All right, so look at this. So they use the Earth curve calculator, and you look at this here. They never read. They're oblivious to these things. It has two things. The following assumptions: the Earth is a convex sphere of radius 6371 kilometers, and number two, assuming that light travels in straight lines. So flat earthers, you need to first show that refraction doesn't exist. You have to falsify Snell's law. Or as some flat earthers say, Snail's law. Lacking that, you need to account for refraction. And what they do is they use conditions that maximize refraction. How many flat earth experiments did they do where they did not see the distant laser light over some distance? And since they didn't see it, they didn't publish. It's a little bit of a publishing bias, if you don't mind. So let's see. All right, before I do this, I don't want to get too far back on these. Hessifer says, your hair looks really cool today. I want to put you in one of my metal videos. Okay. How am I going to be in one of your metal videos? I can't play any musical instruments except for trombone, and I'm a bit out of practice. Not very metal, even though it's made of metal. But yes, let me know how I could help. Matt Patak said, Lakeshore Drive, Stringer News 1 has a member super chat that says Flurfs will only use a straw man of the globe. Very true. Matt Patak says, yep, about Simon Dan. Stringer News 1 says, when has a Flurf ever done the math? Seriously, and you're right. Flat earthers never do the math. They just have their lookup table. Right? They can't even apply. This is great. What percentage of flat earthers could actually apply 8 inches per mile squared if you gave them a calculator? And that deserves a poll, doesn't it? What percentage can apply 8 inches per mile squared? Given a calculator. So less than 10%, 10 to 50%. And there you go. You'll notice that it doesn't go to 100%. Flat Earth Dweller Man, refraction doesn't exist over land. Let's see what Was he in there? There he is. The laser test was over land. Refraction excuses don't cut it. Oh, so yeah. So apparently Flat Earth Dweller Man imagines that refraction doesn't happen over land. In fact, he's wrong. To nobody's surprise, a flat earther is wrong and was using the anti-scientific method to support his claims. To remind you all, the anti-scientific method. Step 1, select your conclusion. Step 2, desperately look for evidence that supports your pre-selected conclusion. It is okay to lie. It is okay to misapply things. It is okay to misunderstand things. It is okay to make things up. This is their method. Any of the, and whatever you can do, it is okay to ignore confounding variables like refraction. That's step 2. Step 3 is ignore disconfirming evidence. It is okay to lie for them. It is okay to ignore evidence. It is okay to just hand wave dismiss things that have been known for a long time. It's okay to say it's just a theory when a theory is actually something that's really, really good. It's okay to claim that a scientific law, is just a theory, as if that does anything. In reality, it doesn't. And most importantly, it is okay to demand a level of evidence that is impossible, right? Well, it wasn't perfect, or there was a margin of error. Oh, you can't do that. So that's fine. And then step 4, declare that your pre-selected conclusion was undeniably proven. That's the anti-scientific method. So, Flat Earth Dweller Man, says that refraction doesn't happen over land. Well, reality chooses to disagree with you. So here I have on my website, mc2.net/refraction, actual measurements of refraction over land. This one here, monitoring the refraction coefficient in the lower atmosphere using a controlled setup of simultaneous reciprocal vertical angle measurements. They use 2 theodolites pointed at each other and targets so that they could automatically measure what happened over time, right? And so I'll give you that. I'll let you read that on your own time. Our refraction experiments came across homogeneously vegetated grassland with ground clearances of about 1.8 meters. That's about the height of a human camera on a tripod, right? Often used working heights in surveying, showing a range of K, which is the coefficient of refraction, between -4 and +16 for sunny summer days. Now, this particular version of K, the coefficient of refraction, I think is using a different version than is used in other places, because a value of +16 is incredibly huge. It's probably not the actual, it's a different application of the coefficient of refraction. Anyway, but what it means is a +16 means drastic refraction, causing distant objects to appear slightly higher, or allowing you to see things that would otherwise, with 0 refraction, be obstructed by, the curving surface of the Earth. So anyway, that's one. There's a bunch of them, including this one is pretty good here. Results of leveling refraction tests by the National Geodetic Survey. Go ahead and read that one. It's not that long. It's very nice. They detailed their methodology there pretty well. And what they're doing here is they're looking at different equations based on the temperature gradient, because they actually measure the temperature gradient. And they apply these 2 different equations to predict the effects of refraction, and then they empirically confirm them with real measurements. This isn't, your math. This isn't just math. This is an application of measurements. Just like I said, in science, you have a hypothesis. You compute the consequences of your hypothesis, and then you test by comparing it to observations. That's what this was doing. The Kukumaki and the Garfinkel equations are computing the consequences of the hypothesis, and then they went and they tested them against observations. So, flat earthers, stop lying. Refraction's been measured. It happens. So, all right. So let's go back to this one here, the Canada laser test. So here's what they did. They did the wrong thing, but because they assumed that there was no refraction. All right, and all right. So here it was above. Let's see here. This right here is the kill shot. Do you see that right there? Flat Earth Dweller Man says, stop strawmanning. I'm not strawmanning my own model. You are. This right here. All right. I got to get back to that later. This is all right. There's Mikey in his car. He went out to 14 kilometers and a hidden of 25 feet, assuming that light does not curve. And the problem is that they didn't pull up any surveys of this area. They just assumed that it was all at the same elevation, but they didn't verify it. I asked Mikey in person if he did that. He said no. He specifically said he did not do anything to confirm that this was all at the same elevation. So was it at the same elevation? We don't know, because Mikey did not check, and he's the one making these claims. Right. So this is, all right, I'll just hit play here. You can see that, but you also see other lights there too. And what you don't see is the lights that are farther. And when he goes to a certain distance, you don't see it anymore. Why is that if nothing's in the way? All right.
Are no magical bulge removing refraction fair.
All right. That was Zoom taboo conspiracy yapping, but look at this. This is the reason why this is the kill shot here. Flat earthers think that lasers are a pencil thin beam, and that when you see it, you are seeing the pencil thin beam. You're not. This laser, which started as a thin beam, has expanded out to illuminate the entire side of his car. He's not seeing a beam. He's inside of a giant cone that goes up and down and left and right all over the place. It's a big cone that definitely is affected by refraction. And we have again, Flat Earth Man who's claiming that refraction could not do it. It's incumbent on you to show the application of perspective. You didn't do it. And let me remind you again that empirical measurements over land do not agree with you. All right. Let me see where it is. Right there. Right here it is. Plus 16 coefficient of refraction, which means that things would be drastically far. If they had simply got a measurement of the vertical temperature gradient, no doubt they would have had significantly stronger gradient than 1 degree per 10 meters. Now this one here is measurements over land in Greece. They got a 0.2 coefficient of refraction. This one here, this is in German. Yeah. Look at the long words. I love the long words in German. This one is very telling. This is on the left side. This is the coefficient of refraction on a sunny day versus time. So you can see here across the bottom, you see it says 12 there. That's I don't know what time that is. It's midnight. I think they did UTC. Maybe not. Anyway, as the sun set, the coefficient of refraction goes up dramatically on a sunny day. And over on the right side, we see the same condition, the same setup, but on an overcast day. And the range of the coefficient of refraction there on the sunny day is 0 to 18. You see that scale? And the range on the overcast day is 1 to 2. The coefficient of refraction hardly varied a similar time period on an overcast day. If you're going to do stuff, do it on an overcast day. Don't do it after sunset. So, and Bob the Science Guy sent a picture here. Yeah, very nice. Less than ½ inch off on drop. Grab this. We can all look at it. There you go. There is his, he says, note the 4 o'clock on the wooden pole. You will see a masking tape box. The auto level is at the level of the bottom of the box relative to the lake level. There's a lake between him and the target. The top of the tape box is the curved earth level. There it is. So, pretty good prediction, 8 inches per mile squared. Works for drop, which is what flat earthers never should do, or never do. You're right, 12 should be midday. All right, let me go back to this one. I don't know why I thought. So 12 is midday. This one specifically talks about sunset, but yes, you're right, 12 is midday. But so in the afternoon, on a sunny day, you can see that the coefficient of refraction spikes. It gets super high. And what do you know about flat earthers' favorite see too far observation? It was a sunny day right over water, right? The one they call the black swan, which is they don't account for refraction. They never do. And you know who's my favorite flat Earth debunker when it comes to refraction analysis? Who is it? You guys know. Who's the best flat Earth debunker when it comes to demanding refraction analysis? You got to know. It is this guy.
Refraction, which we immediately and adamantly claim is always present because there's temperature fluctuation and atmospheric conditions that are consistently affecting what you perceive.
That's right. Witsit demands refraction analysis. So anytime anybody ever says, look at this black swan, you just play this. I have 8 of these and I'll gladly send them to anybody.
Refraction always happens. That's why it's important. Well, if you can't adequately account for refraction, you can't make a claim about the apparent location. Now, can you, Randy?
No, you can't.
I'm claiming that you haven't even actually accounted for all the variables, and you're touting your trigonometry that literally hand waves dismiss one of the most important variables when it comes to perception, which is refraction. And never in your dissecting of the observations do you even account for refraction that we know for a fact to be present. Refraction increases proportionate to the distance. When you just throw refraction out entirely, invoking the furthest point away in the image and saying that you don't have to account for refraction and making the baseless assertion it doesn't move it because you showed us some really not very great images where they look to be generally the same is laughable, bro.
Laughable, bro. So Witsit is dead on there. He's completely right. If you don't have an analysis of refraction, then what are you doing? What are you doing? You need to include an analysis of refraction. And Flat Earth Dweller Man gave me another one that he wants to get this. He wants to get Flat Earth Dweller Man. What are you thinking? You're going to get beat down. You didn't even look. You don't even know. And I specifically mentioned this guy's observation. So let me, is this, oh, it is. It's a trap. Flat Earth Dweller Man, I trapped you. You fell for it. It's so, you just, all right. All right, hold on. Let's see. What is it? So, how much should the ray curve? Well, who would you go to for that? Who would be the person that would be, maybe the guy to definitely check?
The subject matter expert, Andrew Thomas Young, our favorite guy.
That's a good idea, Quantum Eraser. We should definitely do
Andrew
that.
Thomas Young, San Diego State University, Astronomy Department.
Okay.
the subject matter expert.
Hey, Kiwi, you kind of jumped in there while I was talking. In the middle of
So, Andrew Thomas Young, San Diego State University, Astronomy Department, the subject matter expert.
Yeah. The subject matter. I get that.
Andrew Thomas Young, the subject matter expert.
He just can't stop interrupting.
We got our favorite subject matter expert, Andrew Thomas Young, cited here.
Okay, enough, QE, enough. I got it. Andrew Thomas Young, right here. How do you calculate ray bending? There it is. This is it right here. This is the important part, circulating rays. I've read this. I've read several of these different citations that he has here. It goes over the predictions and also the empirical measurements of it to check if the calculations are correct. And so we have here 0.11 degrees per meter. Here we have, let's see, 0.12 degrees per meter. They call it the lapse rate, is what it is. The vertical lapse rate is what is necessary to bend light at the same radius as the Earth. That's what this is here. Let me make sure I get this particular thing here. Anyway, so I put in the chat. I should get General Akbar's "It's a Trap." So, all right, there it is. In there, it talks specifically about 1 degree per 10 meters, or 0.11 or 0.10 degrees per meter, which is all you need to bend light at the same radius as the Earth. If there's more change in temperature than that, then it will cause the light to continually bend down and reflect off the surface of the water. So you're going to get this thing where it hits the water, comes up, hits the water, comes up, hits the water, comes up. And because light expands out into a cone, in these, especially if it's in a laser, you're going to get this cone. You're going to, when you look across the water, oftentimes you'll see across the water an actual smear of the light across the water. And when you see that, that's a sign that the light has been bending and bouncing off of the surface of the water. Okay. So let's go to this particular one here, the Berling gap observation. And if I'm right, they actually measured the vertical temperature gradient here. And the reason why I say that Dr. John D is not a real doctor is because he says he claims to have a degree in some form of optics. And if anybody has a degree in some form of optics, you definitely would expect them to be able to apply refraction appropriately, but he never does. He does it left to right instead of vertically. So, all right, maybe this isn't, it was Brighton that I was in. All right, but anyway, so he has this beachy head here thing. Yeah, this is a different one. So he doesn't have the vertical temperature. He might not. Maybe he does. I don't know. The vertical temperature gradient in this one, but he does at Brighton. That's the one I was thinking of. So, all right, 7 meters above tide level. You can see here the data analysis: tide, mean sea, tide, camera at beach, camera on tripod, camera height, right? None of this is refraction. So where does he take into account refraction? I don't know.
2 meters above tide level.
Oh, and whose voice is that? That would be Karen. Karen B. So we're close. Karen and I are close. She's such a kidder.
Prudent camera height, 8 meters above tide level, or 26 feet above tide level. Berling Gap tide level above LAT, 2 point...
She's just reading it. So, what does Earth curve calculator say?
Let's
see.
According to...
All right. Now here they use the same Earth curve calculator, but they did crop out the part where it says that it's assuming no refraction. Right? They did not do any refraction analysis. And what does Austin say?
Refraction always happens. That's why it's important.
Yep, it is important because it always happens.
To the Earth curve calculator, the hidden height would be 285 feet or 87 meters.
All right. Do they address refraction here?
If the hidden height is 285.
All right. I'm going to see if they have I'll search the transcript for refraction. It turns up that there's no refraction mentioned in the you don't see it on the screen there. I'm searching for refraction. In the transcript, it's not there. Here's the transcript. And you don't see the search bar, but there's no refraction mentioned in there. So, Flat Earth Dweller Man, you didn't include refraction analysis in there. So the problem is, how do you know what it's supposed to be on the globe if you didn't actually test the globe? Because on the globe, we don't say refraction doesn't exist. We say refraction does exist. So, all right. And then he sent me a J. Tolan Media one. So let me make it clear. This isn't quite what we're talking about, but it's on there a little bit. J. Tolan Media #1 is terrible at identifying distant features and landmarks. So his videos are fantastic comedy, but his voice is a little drony. So there's that. So anyway. The time is gone, but I'll save that. I'll save that, Bob. Thank you for that. Okay, let's finish this poll. The poll is what percentage of flat earthers can apply 8 inches per mile squared given a calculator? Less than 10% of them can, according to 90% of you, almost 300 votes. And 10 to 50% thought, or sorry, 4% of you thought that 10 to 50% could, and then 50 to 75% got another 4%. So, and nobody voted for 75 to 100% because we all know they can't. They can't. All right, Gary is in the chat. Poor Gary. Gary's so funny. Gary, what's the formula that predicts the bottom-up obstruction for flat Earth? Uh-oh, Gary doesn't do math. Okay. Let me get back to, I kind of got off track here. So Pat in the chat says, wouldn't trombone be brass metal? I suppose. Trombone was only cool for a short time when ska was cool. So ska is on the outs right now. So Matt Patak is a new member at Einstein. Thank you very much for that. And then Matt Patak says Patak. Oh, it said Patak, Old Bohemian, Polish for bird. Okay, Matt Patak. How's that? William Foley is a new member at Einstein. Thank you for that, William. Stringer News 1 says missing curvature. I didn't get an Amber Alert. And Heat Shield says Toon is a modern day Egon Spengler. I don't know how to take that. I mean, I like Ghostbusters, but is Egon the one that you want to be? Anyway. You're all on steroids. Says, why are you asking these idiots if you've seen the curve? I mean, it's a good point. I mean, there's pictures of the curve. And if you've seen the video I did with, or how Bryce Mitchell accepted my challenge, we're going to debate Bryce Mitchell, the UFC fighter. He's like, in his response to me, he's like, well, he thinks that I have the burden of proof. And flat earthers say it all the time. They try to escape having to provide evidence for flat earth. by trying to say that they don't have the burden of proof because theirs is the default position. In fact, Witsit said that today on one of my posts on Facebook. But no, that's not actually a thing, right? It's not the burden of proof. If you're coming into something, with all things being fair and equal and nothing, then the burden of proof is 0. It's all, 0, 0. Nobody has any default position. That's a fine place to enter a debate. But traditionally in Lincoln Douglas debates, they have a specific roles, and the person that is standing against the generally accepted position is the one that has the bigger burden of proof. So if you're talking about debates, Lincoln Douglas style and others as well, then Flat Earth definitely has the burden of proof, the larger burden of proof. And within science, that's the case as well. You don't roll into science and say, well, I'm going to just handwave dismiss all the existing science and just declare that my position is the default position because reasons. No, if you want to, stand against the position that is generally accepted in science, that is absolutely allowed and encouraged, and you absolutely should do that. But you don't get to dismiss the existing science. You need to address the existing science, right? That's the first step of a revolutionary change in science. Read Thomas Kuhn. You need to show how the existing science is maybe wrong or incorrect or incomplete, and then show the newer version, the updated version, right? And of course, that also, it's all together that you need to actually show that yours is better. And flat earthers saying, "Nuh-uh, globe this, I don't understand globe," isn't actually showing that your position is better, and you are actually coming from a position of weakness when you do that, right? I'm happy to show lots of evidence for the globe. I can do that for plenty. And I've done that here. I've shown how the globe matches predictions over of bottom-up obstruction. And all right. So I think you're not understanding. Flat Earth Dweller Man is sending me videos. Look, Flat Earth Dweller Man, look right up here, right up here. Do you see this? Read that, Flat Earth Dweller Man. Don't send me fake Dr. John D's whining about refraction that he doesn't understand. Send me an observation right there. Location of the observer, location of elevation of the observer, location of the distant object, right? Send me those things. A picture. I'm not going to play a video right now of your stuff, right? If you want to come on and we could discuss it, sure. You could jump me right to it because you've checked it. Okay. But I'm not going to just watch a video in real time and because I can't digest it all in real time here. So, all right, so I'm going to check on, now I posted this on Facebook asking people, and I don't think people did anything on Facebook. My post has 100 comments already. So we've got, oh my goodness. Frederick Michael on Facebook doesn't understand a stinking thing. And I've already shown you, and he's talking about the Chicago skyline. He didn't do anything. Of course, he applies 8 inches per mile squared, and that's it. So let's see what we have here. We have Flat Earth. Love him. No, I don't think anybody's actually challenging and that's the thing. When you actually ask them, well, show me. Give me that observation, right? They don't have it. Yeah, Jeebus says, I told him before the stream even started he would have no link or pictures in the end. What a surprise. So if you think that that video has something there, Flat Earth Dweller, go to the video, get a screenshot of the video, get the details of the location, get the measurements of the vertical temperature gradient. And if you lack that, then I'm going to need the details, right, of the weather conditions for the day. Was it overcast or was it sunny? What time of day was it? Those things. You won't do it. All right. Nobody on Facebook did anything, so no surprise there. Let me check my email here. Nothing from Professor Dave. I wouldn't expect that. So he says, I could send examples of seeing too far for days and days. Okay, and still yet you haven't given me one, right? Look right there, Flat Earth Dweller, right there. I'm asking you to send one, just one. This many. That matches this criteria right here, Flat Earth Dweller, right there. You're not going to do it, are you? You can say you're going to do it for days and days, but you're not actually going to do it. Right? And then the next thing you're going to have to do, Flat Earth Dweller, is provide the plausible mechanism and the way that we can test that plausible mechanism for bottom-up obstruction for Flat Earth when there's nothing in the way. You won't do that. You definitely won't do that. I've seen Flat Earthers at least send pictures. They do send pictures from time to time. They're like, we see too far, but they never actually are too far. They never are. Never are actually see too far. So, all right. Weeboo Metalhead says, game canceled so I can finally catch Tuesday Live. So how much dumb are we dealing with today? A bit off topic. But when you do the Santos doc, he does have a Sav sit past and can't go back to Australia. You're right. Santos Bonacci is such a self-absorbed narcissist that he spent years not paying tolls, driving through toll stations, and got himself more than 100, I think, past due tolls, and had somewhere in the range of $150,000 of tolls, and went to court for that, and there's jail time for that potentially, right? And when it's the quantity that he has, it's a good amount of jail time. So he left Australia. He can't go back to Australia without going to jail. Poor Santos, that's right. He thinks that he is better than everybody else and he shouldn't have to pay for roads to be built because he's that awesome and nobody else is. So, Matt Klein talking about digesting a Flurf video. Flurf videos are to me make me feel like I've overdosed on X-Lax. You wouldn't want explosive diarrhea in the middle of watching a video. So anyway, let's see. So I don't see anything from you, Flat Earth Dweller. So it says, I will be debunking MC Cartoon's laughable take on the firmament in my channel soon. Oh, he even has a channel. That's adorable. How big is your channel? Let's see. On my take of the firmament is simple. Where's the empirical evidence of the firmament? How far is it? How high is it? What's it made of? What? You have one subscriber, you idiot. He has one subscriber. He has one subscriber. It's his mom. All right. Oh my gosh. All right. Well, certainly you will answer all of these questions, Flat Earth Dweller. What is the firmament made of? Why, when you point radar at the sky where the moon or sun or planets are not currently residing, do you not get a bounce back. But when you do point at the moon, you get 280,000 miles. And when you do point at the sun, you get 93 million miles. Why? So answer that in the, at least you get the amount of time that light would take to go that far and back. So, oh, we've got Professor Science joining us. So, all right, hold on a second. Let me get this set up for you. I can science that.
Sorry, right. So late.
That's all right. People can hear you. People can see you. Welcome. I can science that. I'll get your name on the screen too, so people can see you. So the reason why he's, what shall I call you?
You can just call me Matt if you want.
Okay. I didn't know if you'd said your name or not. So Matt did a great video back in, was it June? I think
it was a while ago,
a few months ago, where he addressed the same topic. 8 inches per mile squared is the correct formula for drop. It's not wrong because it's a parabola. Stop saying that. Basically, right? And both Simon and Dan, I haven't seen the Simon and Dan one, so I can't confirm that. But I did watch, and you sent me the one. Professor Dave did say that. So it's the wrong formula, but not because it's a parabola. So anyway, welcome, Matt.
Hi. Yeah, thanks for having me. Yeah, that was the main point I wanted to make. Was that really the key difference between a science denier, a science contrarian, I like to call them, and, the debunkers is supposed to be that the debunkers carefully check their facts and they correct themselves when they make mistakes, right?
Yeah.
And so, of course the flat earthers are going to get it wrong. There's no news there. But if we are getting it wrong, then that's actual news, and we should do something about it. So I'm really glad to have you getting the word out so people can make some corrections.
Yeah. And thank you for that. And so there was, we had a little interaction in the comments there. So how this came up though, I think it's important. Rachie 50 2 or 3 days ago actually did a video on your video.
Yeah.
And I at the time I was subscribed to her on my main channel. And so I got the notification. And so I'm like, oh, let me go look. And so she maybe didn't quite make it clear enough that you were talking about drop versus obstruction.
That's possible because I did 2 of those videos. The first one, I think I did make it pretty clear. But in the second one, I didn't mention it really at all. So it's entirely possible that people saw that second one and just kind of ran with the idea that, oh, I'm saying 8 inches per mile squared is good, because it is good if you use it right. And it's really rare to have somebody use it right. It's so rare that it's worth noting when it happens, really.
Yes. Yeah. I put your link to your channel in the live chat, and I'll put it in the description as well. So people, I definitely recommend that you subscribe to him. I do. It's good stuff.
Greatly appreciated.
You actually spoke with, what's his name? The guy from the military that did his sun angle measurement stuff.
Yeah, Corey
Kell.
Corey Kell, right?
Yeah.
Had a really long, really pretty pleasant discussion with him about his ideas, and it went about like they always do. Although no, I take it back. It wasn't a dumpster fire, so that was really nice.
Yeah. Yep. And of course, Corey Kell's problem was he was to summarize for people, he was doing these, I don't know, vertical measurements or horizontal measurements. I think it was essentially a horizontal. Anyway, measurements of the position of the sun, and he was predicting it based on some wacky math that he was doing that wasn't correct. There's online calculators that use the globe model to predict where the sun will be at any particular time, but he didn't use that. He used some other stuff. The geometry was all wrong, and then he concluded, based on his wrong geometry, that it didn't match the globe. It's a common problem we see all the time. They do science wrong, then make the wrong conclusion. And he did say, and I don't know if you got this from him, but he did claim that it did match the flat Earth.
Right.
Something I didn't see in any of his videos his actual how he predicted the flat Earth.
Well, you won't be too surprised by how that works. The through line of his logic is that the sun moves at 15 degrees per hour. So in 3 hours, the sun moves 45 degrees. Right? And
yes.
so 3 hours before noon, the sun must be 45 degrees away from straight up. So this is his logic, is that 3 hours before and 3 hours after noon, local noon, the sun must be lower than 45 degrees. And if it is ever higher than 45 degrees in the sky at those times, then that disproves the 15 degrees per hour. And then, and it sounds really good. I mean, as I say that back, I could easily be convinced. In fact, when I analyzed his stuff, even I was like, that sounds pretty good. I'm going to need to take a closer look at that. And only when I took a closer look, I was like, yeah, that's not right.
Yeah.
But with the flat, the logic goes, it's amazingly biased how they compare globe and flat. They will say with the globe, it's this strict 15 degrees per hour, and with flat, there is no 15 degree per hour limit, and therefore it matches their model because there is no limit.
Because they don't even have a model.
Because they don't have a limit, and so that was as far as he took his analysis. On the other side is that the rate that the sun moves through the sky is not limited by 15 degrees per hour, and therefore there is no limit with flat. And yeah, when I made him a little picture of what the flat Earth looks like and where the sun should be, and it didn't really seem to click.
No, and to be honest, he's not very bright. You can tell. He's like, this is military science. No, it's not.
Yeah, it's hard to judge when someone is just not mathematically talented, as opposed to when someone's bias is so strong that they cannot overcome the bias in order to do the math.
That's true.
It's a known phenomena of the human condition that our minds can be so biased about something that we are literally unable to do the math if the math goes against our biases.
Yeah. So you brought up that the dual standard, right? That when they are evaluating globe evidence, they are exceedingly strict, and they will constantly move the goalposts and constantly increase the precision and accuracy demanded. Right?
Exactly. I mean, like there's a classic example in the chat of this show. You have a flat Earth. What is it? Fellow flat Earth somebody dweller.
Flat Earth dweller. Yeah.
Yeah. Flat Earth dweller in there is just insisting that refraction to save the globe would be completely inappropriate thing to do. We must never do that. And I wonder, has he ever looked at a photo of a distant object where you cannot see the bottom of it, and said to himself, that's because of refraction or compression or whatever ad hoc excuse he wants to use. And does he not realize that you must, you can't, like the famous black swan photo, there's two of them, right? There's the one on the clear day where you don't see the bottom of the oil rigs. And then there's the distorted one where you do see the bottom of the oil rigs. So if the one disproves the globe, the same logic says that the other disproves flat.
Yeah.
It's the exact same logic. And yet somehow we don't apply the logic.
The dual standard. Yeah. So, all right. So when they use, they're basically science deniers when evaluating globe evidence. And when they're looking at flat earth evidence, anything goes. It doesn't matter. Everything is good enough for them. And so it's one of my laws of FLIRF. I have 3 of them. FLIRFs are pseudoscientists when evaluating flat earth, and science deniers when evaluating globe evidence.
Absolutely. Yeah, in fact, I go so far, this is something that I've picked up over the years. I have discovered that flat earth isn't because they believe the earth is flat. It's because they don't agree with whatever they're being told.
Like they're contrarians.
Yeah, they're contrarian. They're being contrarian about it, and that's the important aspect of it. So that's why you won't see a lot of positive evidence. I believe it because look at my evidence. It'll be I believe it because NASA lies.
Yeah. We got. The chat is always so fun. We've got Gary Wybenga in here saying that the sun moves across the sky in 15 hours in the summer and 10 hours in the winter. They can't both be 15 degrees. He doesn't have any idea that it's an arc across the sky.
Interesting. That's Gary. That's exactly right, and that's the piece that Corey Kells had missed as well. It is 15 degrees per hour. And it does take more than 12 hours to cross the sky in the summer. Those are both true statements. Can you work out how that works?
It happens in 3 dimensions, not 2.
There you go. It's a 3-dimensional problem, and with the tilt of the Earth, that brings that in. And Gary, if you're having trouble picturing that, the secret is picture it at the North Pole. You know that at the North Pole, the sun never sets, and yet it still moves 15 degrees per hour. Right? If you can put those 2 facts together, you'll have it. You'll be like, oh, now I get it.
The thing that they miss is that this is stuff that people have known about. If you ignore the shape of the Earth stuff, people have known about the movement of the sun, and they don't disagree that it moves 15 degrees per hour. Flat earthers don't actually disagree with it when they actually look at its movement. But some are just so miss the geometry of it that they'll actually claim things that it is just factually incorrect in a trivial way.
Right. Well, I mean, to be honest, the geometry is kind of hard. I'll be fair about that. So not getting it right away is super understandable.
Yeah. All right. I have a message from Lael who says, this is on point. He says, the fact of the matter is that there are thousands of miles of water beyond the furthest oil rig and the land masses west of that oil rig. How far is too far? We didn't see them. Right?
Right. Right. Are you saying like we're talking about black swans here?
Yeah, it's the black swan again.
Yeah.
Like,
Yeah, absolutely. I mean, all I really ask is that we apply our logic fairly. Try that once in a while. Try just whatever logic you want to apply it equally, and see where that gets you.
yeah. Now, are you familiar with Gleam?
Yes, I'm aware of Gleam.
So Gleam, I love Gleam.
Is he on right now?
No, he's not.
Okay.
He has he works a regular job. He writes GPS software. On websites that does placement. I don't know exactly what he does, but he interacts with GPS sometimes. He knows the Earth is a globe. He doesn't hide that.
I was gonna say because yeah, that was my assessment as well.
But he's a contrarian too, right?
Mm-hmm.
But he's bright enough to know that the Earth is a globe, but contrarian enough to not want to accept it. So
Are you sure he's not just playing?
I mean, yeah, that is what he's doing. He's a contrarian, so he has to, he wants to engage that. And he's like, well, maybe the Machian principle applies, and it can both appear to be spherical and flat simultaneously because of the Machian principle. Well, no, because still all of the flat Earth stuff doesn't work. But he goes after that, and he's constantly citing scientific studies, which is better than most of the flat earthers do. So it goes to your point though. He's a contrarian, but smart enough to know that the Earth is a globe, but just as a contrarian, he can't handle it. So
Can't or won't. It's hard to say, right? I mean, I got a question. Maybe you can do a poll on this one. How many globers in your chat have pretended to be a flat earther?
Okay.
I'm curious to know that. Be honest. It's anonymous.
Yeah, I cannot see your answers.
Have you ever pretended to be a flat earther?
And to the point, flat Earth is nonsense just said, hold on, just said I pretended to be a flurf on TikTok and went from 11 followers to 30,000 in 3 days.
Yeah, so
wow.
That's an anecdote, but maybe some other people will come out. I have seen one poll before that said 90% of flat Earth postings were pretend. It was, how many have ever pretended? It was versus how many are actual flat earthers. It was 10 to 1, not 10 to 1, 9 to 1. So,
I don't think it's, I've interacted with them on Facebook enough. I don't think, because you can go to their Facebook page and you can look at their Facebook page, and it's not just flat Earth, right? It's the entire smorgasbord of everything. They took their plate to the buffet of conspiracy nonsense and filled it heaping with every single thing at the buffet. Yeah. And you can scroll back in time and see page after page after page of every single thing out there. And then you hit where the posts aren't super regular, and it's pictures of their dog, family pictures, vacation pictures. Like, wait a second. On this month of this year, that person went from normal human to believing every conspiracy nonsense out there.
So that's really interesting. You found that they go from 0 to flat Earth in one step? Or
I don't know the time frame, but if you look at the timeline of Facebook postings, right, which doesn't tell you what they were doing in between, and probably if you look at the psychology and sociology of it, right, they'll happen on a video. It's almost always a video. And they're like, oh, I mean, how many times have we all heard, well, I watched a video and I had to try to debunk it, and I just couldn't debunk it. And once I couldn't debunk it, then I had to accept it. That's probably for a lot of them a couple weeks total, but they don't want to publicly do it because there's a stigma, as there should be, right? You're not the bright one. And so I think they go from thinking the earth is flat to posting about it is a gap. Don't know.
What I'm curious about is which other conspiracy theories did they hit along the way? I've heard some people suggest that flat earth is actually a gateway conspiracy theory, but my working hypothesis is the opposite, is that it's the terminal node of conspiracy theories.
Yeah, because there aren't a lot farther, right, that people generally go to, like some people say reptiles, right? That the ruling elite is actually reptiles. But that does require, some shape-shifting type things, which people I think are generally not accepting of.
Yeah, I mean, like, do these Facebook
I don't know what's past
progressions? Do they hit JFK, a couple of JFK posts first, and then some moon landing, and then QAnon, and then flat Earth, or do they just like dogs, vacant, flat Earth?
I shouldn't. I don't know from memory, what the Facebook profiles actually look like.
That would actually be an interesting thing to do a little study on. To actually collect data.
There you go. Psychologists, people working on your doctorate in psychology. There it is.
Yeah, that could be really good.
So Mute Donkey says anti-vax and moon denial is common. But I think these days there are moon deniers that are not flat earthers, but I think the bulk of the moon denier community by far is flat earthers. Now,
you think?
I think so. Because
I'd be surprised by that.
And I guess I don't run into. I'm not in moon hoax groups on Facebook. I'm in the Flurf groups. So
yeah, I think you may be in a bit of an echo chamber there.
Yeah, that could be.
You're convinced.
Keith M says, I fear every time I start a new physics class, I start one tomorrow, that I will encounter more Flurfs. MC Toon and I can science that. So where is this?
No.
Where are you teaching these science classes, or are you a member of these science classes? And is it at a university or at a high school? That'd be interesting, Keith.
High school.
But yeah, what is beyond actually flat Earth for, is it the bottom? I think it generally is the bottom. There isn't a whole lot past it.
Yeah, I mean, my working hypothesis is that when you see that video on YouTube, that flat Earth video, there's two ways to go. You scoff at it and chuckle and you move on, or you scoff at it at first, but you don't chuckle and move on. You dig in because you're predisposed for some other reason. And I think normally you would find that predisposed person already believes many conspiracy theories before they're willing to accept flat Earth.
Keith
that's my theory.
All right. Keith M is a university professor.
I'm curious then, Keith. You haven't
class.
actually had a flat earther in physics class before, have you?
He says he hits them more often, which implied to me that he's gotten them in the past.
I would love to talk to him about that.
Hey, if you're here, Keith, if you don't, being a professor, I understand this might not be something you want to do, but I think it'd be a great conversation if right now you were interested.
It was one of my students who tipped me off about flat Earth in the first place. But
he said I've had 3 in my last class.
What?
And in university. See, to me, that's an instant fail. Get out of here.
Well, I don't know. I mean, if they can learn in physics, they can turn it around.
I suppose.
Keith, send me an email or something. I got to talk to you about that. I'd love to hear that story.
Keith, MC2 at mc2.net, and I'll grab your email quick for him. Where you teach? What do you teach, Matt?
I teach computer graphics mostly. Yeah.
Okay. So, Photoshop?
No, 3D stuff,
Oh, okay.
like programming.
The programming 3D stuff. Right.
Yeah. Yeah. Programming and programming computer graphics.
Oh, wait. I'm not on video. You don't see me. There you go.
Oh, hey,
You can
hi
see
there.
me. Can you tip your camera down a little bit? You're really low on the frame.
Okay, yeah, I can do that.
People said you're short. Now you're too tall.
Now I'm too tall.
There you go.
How's that?
Perfect. All right. Keith M says yes. I think that means that he can come in. So send me an email, mctoon@mctoon.net, and I'll send you a Zoom link, Keith, if you want to join us quickly.
Yeah, I would love to hear that story about flat earthers at a university physics class.
Oh, he can't do it right now.
Bummer.
Okay.
But maybe later. Definitely want to hear that.
Yeah, that'd be good. You can do it on your channel. We can do it here, whatever.
Yeah, actually, I hit up the physics department at my school to see if they had a Cavendish device, and because it's on the inventory, but we don't have it anymore. They threw it away. They literally they threw it away, and because nobody cares, it's boring.
Yeah,
because we don't have flat earthers in physics class. But yeah, if you have a flat earther in physics class, break out the Cavendish and just run it during lecture one day, just in the background.
Have you heard the attempted refutation of Cavendish?
Oh, I've heard several, but none that made any sense.
What's the worst?
The one that I like the best is that it's electrical somehow. Although they say it's electrostatic, but sometimes they say electromagnetic, and I'm not sure what they mean. I think they mean electrostatic, and I mean, and then they go on with the electrostatic potential between the surface of the Earth and the clouds or whatever. And I usually just get a big old smile on my face and point out that if it were electric, I mean, it's obviously not, but if it were, that would be gravity, and then that would force the Earth to be a sphere as well.
Exactly what Witsit posted on Facebook. He posted a video to Good Times for All, another flurf that the Globebusters love, who said it's incoherent magnetism, and went through this whole thing, which none of it, you're not going to find this in Maxwell's equations. He said that because molecules, not atoms, molecules, which is what many things are made of, but not everything, have they're imbalanced, right? So they're polar. Yeah, they can be polarized, and you can have a slight positive on one side, a slight negative on the other. I think maybe he actually tried to claim that atoms do that as well. Like the cloud of electrons will shift over to one side. Maybe.
In a strong electric field, they will.
They would. A strong field, but I don't know what field they think that. Anyway, so if that's the case, and they put together a whole bunch of magnets in a blob, right? But these aren't a whole bunch of whatever. In the end, it was that all things have this particular setup, and therefore all matter will attract all matter.
Right.
Which is what gravity does.
You can like argue with them and try to point out that it's super obvious that it's not that, but let's just say it is. Let's just say that all atoms are attracted to all other atoms because of the electrostatic force. And that it's an inverse square law because of Coulomb's law. Congratulations. You just discovered gravity. we're done.
Well, sort of, but
I mean, it's Coulomb's law, right? Do they deny Coulomb's law?
no, they try to use it.
Well, that's what I'm saying. Coulomb's law and the law of gravitation have the same form. So if you just
Yes.
swap out Coulomb's constant for big G, it's gravity. And
Well-
so if all atoms are attracted to all atoms, large collections of atoms form spheres.
Yeah. Well, it's worse than that though, because it's based on charge, and they don't quite understand
Well,
that.
yeah.
They're like,
Well-
well, there's this electrical charge in our atmosphere. Okay, well, I have right here this handy little book called The Foundations of Electromagnetic Theory. This was the book I used at university. I sold after my class and have now since repurchased it. Gauss's law right there.
Hmm?
Right? Gauss's law is a field. The force that's felt on a particle by a field is directly proportional to its charge. That's the number of the Q on the top, and inversely proportional to the radius squared, and some constants. So the charge of an object, if it's neutrally charged, is going to feel nothing. Well, that didn't help you very much there. But if it's positive, even slightly positive, if it's just electromagnetism, you'd go up. And if it's even slightly negative, you'd go down. Or the other way, depending on the field that it's in.
Yeah, I mean, I was talking to a flat Earth friend of mine. He's a fairly reasonable guy, but he's a
In
flat
real
earther.
life?
Online.
Okay.
And he brought up Witzett's electrical whatever, and I laughed, and I said, take a balloon and rub it on your head, and then notice that it still falls to the ground. It doesn't. You didn't change its weight at all.
Yeah.
And yet, if you stick it to the ceiling, it'll somehow create like an anti-gravity field and stick on the ceiling. Right? Doesn't that right there just prove that it's not the charge? You take a neutrally charged balloon and you put thousands of volts on it by rubbing it on your head, and its weight does not change.
But it goes to their science denialism, because you say neutrally charged and they'll say, oh, but wait, is it really purely neutrally charged, or is there a minuscule tiny little charge one way or the other?
Well, I'm happy to grant you there's a tiny little charge on there, but I just put on thousands, tens of thousands of volts by
Yes.
rubbing it on my head.
It didn't change.
So it went from tiny minuscule to huge. Let's just make a graph. Let's put different charges on the balloon and weigh it at each time, and just graph weight versus charge.
Oh, and here's a beautiful one from Flat Earth Dweller FE. Drafts cause the deviations in Cavendish. Somehow there's a draft in a vacuum chamber.
Well, and not
How
only
does that
that,
happen?
but the draft always goes in the direction of the external mass,
Weird.
which is kind of interesting.
You'd expect it to go half and half if it's drafts, right? Random directions.
But not only that, but the draft power always happens to work out to within a tiny fraction of what everybody else's draft
or
is.
5 digits precision deep somehow. How is that draft
Yeah.
so perfect? He says also, this as does the torsion of the string. Actually, it's quite the opposite. When the test masses are not there, you allow the string to come to where its natural resting position is, eliminating the torsion that you speak of, and then you introduce the masses. So introducing the mass out at the ends of the bar somehow affects the torsion of the string at the middle. I'd love to see the computation of the consequences of that particular claim.
Well, I mean, it's just your standard bias approach. It's if there's anything that goes against the pre-selected conclusion, we will accept any excuse, no matter how flimsy. It can be drafts, even though all of the professionally made versions of the Cavendish rig, I mean, he may not know this, but you can just buy one. It's like $1,000.
Yep.
and high schools have them, colleges have them. You can just go and buy one yourself. And they have a layer of plastic, clear plastic between the torsion beam and the external masses. So this draft you're speaking of is a vortex going on inside a sealed container, I guess.
And it's always the same direction at the same.
And it's always
quantity.
the same direction of the masses, and it's always in approximately the same amount. So, but that's a perfectly acceptable excuse to refute this point. But when it comes to something like, why does the sun set? The response, well, we don't know what the sun is perfectly good. That's enough. That's okay. That's right. Amazing how skewed the bias is on that.
He says, he comes back with the amazing, even professors have a difficult time setting up the experiment, as if somehow an experiment being difficult disproves that the experiment works when it's done right. I don't know how.
Yeah, but didn't I say you can just buy one of these?
Yeah.
I mean, professors don't have a difficult time setting them up. We buy it from Fisher, or there's a few companies that make these things. You put it on the desk, you let it run. It takes a couple of hours. I mean, if you guys ever saw Blue Marble do it, it takes a while.
It's not exciting.
They're just like that big.
Yeah. And like BM Furball did it. He didn't, and his intention wasn't to measure the actual constant. His was just to test the hypothesis of whether or not mass attracts mass.
Mm-hmm.
Right. So
yeah, he did a nice one.
And so when university professors have a hard time doing it, is it that they have a hard time doing it such that the results are sensible, or do they have a hard time doing it where it doesn't even work at all? I don't know. He says don't sphere the truth has a compilation of them.
I mean, if you just slap one together using string and bowling balls, that's probably not going to work too good.
I saw a flat earther use a chain for the torsion wire. Like the chain is, what's the torsion coefficient of a chain? Oh my gosh. All right, hold on. I gotta. String News 1 says, MC Tunes, so you're saying that what you're saying is that they become conspiracy theorists after some event, like they got abducted by aliens.
That'd probably do it. I'd say that'd probably do it for me.
Like, hold on. But then the flat Earth is flat. Where did the aliens come from? Pilo 1408 says there is a non-flurf moon denier who occasionally comments on MC Tunes' channel. He goes by Ryan something or other. Oh, I don't do a lot of the moon hoax stuff. So I wouldn't expect it, but all right.
Yeah, I like I think it was Kat's approach on that when the flat earther brings up moon denial as his reason for flatness. Katz used to just be like, fine, let's just say the moon landing was fake. How does that mean the Earth is flat?
Yeah, it doesn't.
It's like, you mean I can't fake a landing with a flat Earth? It's not possible to make that video if the Earth is flat? Or wait. I can only make that video if the Earth is flat. I can't make fake videos on a globe Earth. That's the logic.
Matt Patak says flurfs talk about indoctrination, but question it. And it's projection when they talk about indoctrination.
Although I'll say it again, the reason I made that video, and I want to make sure everybody catches this, is don't go around saying it's a parabola, because you're making us sound like we're just indoctrinated. Right? You're just repeating something you didn't check.
Yep. All right. William Foley says, did either of you see Blue Marble versus Bev debate? Was this recent? William Foley. I didn't see anything recent.
Watched it / listened to it last week.
Okay. I have not. I'll have to check it out.
Yeah, it was good. I'd watch the beginning of it. They're two intros really. And if you've ever seen anything with Bev, it's not going anywhere. So
yeah, it's as useful as a soup sandwich.
Soup and sandwich? That's good, right? You dip it.
You take the bread and you ladle the soup on it, right? And then you put the other piece of bread on it. I don't know.
I like it.
Might get a little droopy on the bread.
Well, are we talking bread bowl here? Because
bread bowl does not a sandwich make.
Oh, I think there could be a follow-up debate to the hot dog sandwich debate. Is a bread bowl a sandwich? Is Mallory in there?
If you put the lid on, if you put the lid on a bread bowl, is it oh my gosh, no.
See, is there meat or veg and sauce in there? I think there is. There's a point you could make.
Depends how absorbent the bread is. Mallory was going to be here tonight, but she's sick.
I hope she feels better.
She was going to debate.
In that case,
Brian.
We should get Team Skeptic in here.
We should, since
Mallory's not available.
I sent her the Flurf wiki for her. Whoever wrote it did a masterful job on the Flurf wiki for Mallory. It was we all like her so much, and it was very nice to her and super funny. So she liked it.
Well, thank you so much for having me on. I do got to get going.
Okay.
I did one last little plug I wanted to drop on you was our discussion was largely about whether Raichi was like off the rails with this thing.
True. Yeah.
I actually think, it's always hard to have a really understandable conversation across such a great divide of, a flat earther and like a mainstream science person. But I had the impression that Raichi was just commenting on Dave, on Professor Dave Explains video. And in that respect, I'm going to say Raichi had it right. She did not specifically mention hidden height in her video. And so then I did follow up with her in the comments and asked her, do you understand that drop is different from hidden? And she actually said, yes, unless the camera is at ground level.
Yep.
And yeah, I'm going to say technically she's right. Yeah, and you can even do the two-step process where you use 8 inches per mile squared to get the distance from an elevated viewer to the horizon.
No,
in one step.
They use square root of 1.22 times the square root of the observer's height in feet.
But it's just the inverse.
Yes.
It's just the inverse
You're
of the equation, right? So yeah, you just take use algebra, which if there's a flat earther who can do that algebra on their own,
it's Raichi that could. Raichi could.
Raichi could do it. Okay, yes. There you go. That and flat Earth math was in her comments explaining this as well already. So I know she knows this. You can use the equation to get the distance to the horizon. At that point, you're mathematically on the horizon. So if you take the distance from that point to your observation, you can do 8 inches per mile squared to get the drop there, and that is the hidden amount. So I think she actually maybe gets it. Maybe.
But still, she's got that barrier.
The one thing that I ask us, those of us here, is to be a little bit patient with somebody like that, who maybe they get it. We have a chance at least to have that conversation. But if we immediately jump on them and say, oh, no, it's wrong because you're not taking observer's height into account. then they have at least give them the chance to say, oh, I'm not talking about hidden height, or this only works from ground level, or something like that. Just give them a chance to be right. There's nothing wrong with them saying true statements once in a while. It's not a team sport, right? We're not trying to tally up correct points versus wrong points on our team or something.
Exactly. And I say that with debates, like who won the debate. I debate every week. I've had been in many debates, and I don't ever talk about who won or didn't win, or somebody demolished, or I don't generally do that. So.
All right. Well, thanks so much for having me on.
Yeah.
And have a great night.
Thanks for stopping by, everybody. Matt's channel is in the description, and it's pinned at the comment there. And the poll, let's see the poll here. How many people have pretended? Hold on, you're still here. We got to give you the answer here. How many have pretended to be a flat earther? Yes is 14%, 13%, because YouTube can't do the math right. No is 86%. So there's 1% undecided. So 13% have pretended.
That's not a small thing. If you consider that of your, I don't know, maybe you have 100 viewers, you've got maybe 2 true flat earthers or two supposed flat earthers in your chat. So the math
we got 3.
says
we got 3, I think.
The chances of encountering someone at random, if you encounter someone at random and they claim to be a flat earther, chances are they're faking.
Yeah. All right.
So that's just what the poll says. It's a very skewed poll, though, in this particular environment. Okay.
Awesome.
Good night.
All right. Thank you. All right. Remember, go sub to him. I'm going to check right now. 843 subscribers. 843. How many of you are there right now? 429. Now, unless all 429 of you are currently subscribed, you better jump over there right now and it costs you nothing. It costs you nothing to subscribe to him, and it's very meaningful to him. So be kind, rewind, and subscribe to Matt there. So there you go. If you're already subscribed, go sub with your fake flat earther account that 13% of you say you have. All right. So yes, I'm gonna have to watch. I did not know that Blue Marble Science and Bev had this debate. I will definitely watch that. Yes, I'm sure that Bev said horizontal 200 times and had no measurements. That's my guess. He has no measurements. He's just trying to declare that because of geometry alone, it must be. So, all right. There it is. Thank you for this. I hope this has been good. I hope that please do not do this, do it wrong. Flat earthers, please stop being dishonest. If you're going to test the globe, test the actual globe, not a straw man of the globe. Because if you, to be honest, really, if you test a straw man of the globe, all that you did was debunk a straw man of the globe. Who cares? You didn't do anything. So, Gary, it's to you, Gary Wabenga. How do we compute the consequences of all your claims? What is the plausible mechanism that causes things that are not obstructed to become obstructed? And then how do you apply? You say it's Rayleigh criterion. How do we actually apply that? What's the formula to apply the Rayleigh criterion to having something disappear? Just not be unresolvable, which is what the actual Rayleigh criterion is, but to be gone, and then the vertical space where it used to be get gonified, and the stuff that was up here, right? So this is the horizon. This is the part that's being obstructed, right? It gets gonified, right? If there is the top of a building, that top of the building didn't stay there when this moved down. The top of this building also went down with it. Why did the top of this building way up here get affected when this was gonified? I don't know. This you, Gary. I don't know. Makes no sense. Matt Puttock says, did you think Bev listened or didn't shut up? Bev did not shut up. Bev did not listen. He does not care. He uses the anti-scientific method. None of his stuff matters. None of anybody else's stuff matters. All that he cares about is one thing, that he says geometry is the only thing that matters. He doesn't need to go do any observations. So, all right. Gonified, this word is very scientific. Very, very much so. So here we go. Speaking of people pretending to be flat earthers and people not pretending, definitely quantum degreasers not pretending. Flat Earth Dweller did not pay attention. Let me check one more time to see if he brought no observations matching the requested thing. So anyway, Flat Earthers, if you think that you have an observation that's too far, bring it. Let's test it. Send it to me. Email it to me. Send it to me on Facebook or Discord or Twitter. You won't. You do not want to have your claims tested. Cult members and cult leaders never want their claims tested. So, further, Flat Earthers, what's the plausible mechanism and how do we compute the consequences of your claims for what is causing the bottom-up obstruction? What's the formula for it? That is science, to make a prediction. Flat Earthers try to redefine science. They have to. You have to redefine science because science so trivially falsifies Flat Earth. So anyway, next week I got a full plate. I have 2 debates at least lined up. Hopefully they stick through. I'm working on a Jaren video. I'm trying to get the script just right. So be looking for that on my Conspiracy Tunes channel. I don't know exactly when, but I'm working on that. So thank you everybody for joining. And I hope that you enjoy a very metal Christmas.